This is lesson 9-4, and we are dealing with perimeter and area in the coordinate plane. I am on page 616, so if you would turn there with me, please, and we will get started on this lesson. In lesson 9-3, you estimated the area of irregular shapes by drawing composite figures that approximated the irregular shapes and then using the area formula to give an area for that shape, for that irregular shape. Today we're going to talk about another method. Another method of estimating area is to use a grid or graph paper and count the squares on the grid. All right, so let's start by looking at example 1. Estimate the area of the irregular shape. Here is our irregular shape, and we are going to look at two approaches to finding the area of that irregular shape. The first one is more similar to what we did in lesson 9-3, where we take this irregular shape and we draw composite figures in it or specific shapes in it that we can find the area of. So you can see they've drawn a trapezoid here, a trapezoid here, a square there, a rectangle here, trapezoid, triangle, etc. And then they have roughly found the area of each of those shapes, and then they've added them together to find that the area of this irregular shape is approximately 36 units squared. Let's see, I was going to tell you something else about that. Let me think for just a second. Oh, remember, this is an approximation. So I say approximately and I mean it. You're going to have a little room for error in this problem solving. All right, method 2 is not to do it quite as mathematically, but to take time to count each square. And I do remember, I'm pretty sure, a problem that Joel and I worked on the SAT. No, actually, that was the ACT that was similar to this. But here, we're going to count every whole square, and we're going to mark it somehow as being a whole square. So you can see that that's what they've done. They've marked this one as a whole square because it is, this one as a whole square because it is, this one in the same way, etc., all throughout this shape. But then they decided on a symbol for a half a square. Now, if I were doing this, I would find something quicker to write in the picture or draw in the picture than those two shapes, like maybe dots and dashes or something like that. But you can see that all the ones that are not whole squares, they have filled in with a little half triangle. Again, that would be very time consuming, so come up with a better systematic approach. But they've put that in every partial square, as I'm pointing to for you. And so and they didn't really think about, is this exactly an entire half square? Because sometimes it's not. If you look at this one, it's not an entire half square, but they called this one a square, and it's not actually an entire square. Do you see that part right there that's not covered? So again, this is an approximation. But they then went through and they added all the squares, which they said added up to about 31, and then they added all the half squares. So they counted all the half squares and they said those are worth half of whatever that number is. So they said this is 31 whole squares plus half of 13 half squares. And that gives us the number 37.5 as our area of this irregular shape. And you see we have 37.5 here and 36 here. Very close numbers for approximation. All right, so now let's look at the check it out number 1. We're going to do the same thing using one of those approaches with this irregular shape. I'm trying to remember what I chose. I chose to count the shapes. I didn't even mark them. I just went through and I said whole, 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 and I counted as I went. So 1, 2, 3, 4, 5, 6, I counted that one, 7, 8, etc. And I counted approximately 31 squares. I then counted approximately 13 triangles. So for the partial squares, I would have counted 1, 2, I probably didn't count that itty bitty piece, 3, 4, 5, 6, 7, I might have counted that one, etc. Remember, because it's an approximation, you have some room here. Like I wouldn't have counted those two tiny little pieces right there. Might not have counted those two tiny little pieces right there. But you're approximating, so that's okay. So I said 13 triangles. So then to do the math on that, I needed to say 31 were complete squares, 13 were partial squares, so I'm going to treat them as a triangle and count it as half of a square. So I said 31 plus 1/2 of 13, and that gave me 38.5. I think the answer that the book gave was 38 units square. I'm seeing that I forgot to put my square. So again, a very close approximation. All right, I am going to stop that video and we will start with video 2.